Hello my dear students, welcome to my YouTube channel that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today we are going to do about the third case of Vsepr theory, that's valence electron pair repulsion theory. And the third case deals with the comparison of bond angles in same type of compounds with the decreasing electronegativities of the side element belonging to the same group of the periodic table. In this case, we are not talking about the electronegativities of the central element. We are talking about the electronegativities of the side element. For this case, let's take the example of halides of phosphorus. So I'm talking about the halides of phosphorus. The general molecular formula of halides of phosphorus is px3. So we are talking about the halides of phosphorus. That means we are talking about the same type of compounds. We are talking about the same type of compounds. Now in case of px3, P is our central element, which is phosphorus, and X is our halogen, and that's also side element. So we have to deal with the electronegativity of the halogens while talking about the bond angles in this case. Now we all know that halogens belongs to the group number 17 of the periodic table. So the group number 17 is fluorine, chlorine, bromine and the iodine. Here phosphorus will combine with fluorine to form halide PF3. Phosphorus will combine with chlorine to form PCl3. Phosphorus will combine with bromine to form PBr3, and phosphorus will combine with iodine to form PI3. Now, all these compounds are of same type and they all will have the hybridization to be sp3 with one lone pair in main structure and 3 bond pairs in main structure. So whenever the sp3 hybridization has one lone pair and 3 bond pairs, then the name of that geometry will be pyramidal. Now we have to deal with certain trends down the group. As we move down the group, usually the electronegativity of the halogen decrease. So I am writing down the group, the electronegativity of halogens decrease, due to which what's gonna happen? Due to which the bond angles in these compounds which I have mentioned will increase down the group. Now let's talk about why. Why bond angle is increasing down the group with the decreasing electronegativity of the halogen, or we can say the side element in case of halides of phosphorus. So let's talk about it. I'm taking the example of PF3 and a PCl3. Now I'm drawing the structure. First of all, that's the phosphorus is sp3 hybridized with one lone pair and three bond pairs. So that's the first bond pair with first fluorine. That's the second bond pair with second fluorine, and that's the third bond pair with the third fluorine. Now, we all know that fluorine is the most electronegative element of the periodic table. So here, fluorine will attract the shared pair of electron towards itself. So, in the first bond pair, fluorine being the more electronegative element will attract the shared pair of electron towards itself, thereby acquiring the delta negative charge and the delta positive charge on the phosphorus. Now, the second fluorine will also attract the shared pair of electron towards itself, thereby acquiring the delta negative charge, and a delta positive will be formed on phosphorus. The third fluorine will also attract the shared pair of electron towards itself, thereby acquiring the delta negative charge, and again phosphorus will acquire a delta positive charge. Now, after that, what's going to happen? That's the lone pair of electrons. Lone pair of electrons is a kind of negative charge. Now, like charges repel each other. So, this negative charge on the lone pair will repel the delta negative charge on fluorine more strongly, because the magnitude of delta negative on fluorine is much greater, because it's the most electronegative element of the periodic table. So this lone pair will repel the fluorine atom acquiring the delta negative charge. So I'm writing strong repulsive forces. Strong repulsive forces between lone pair of phosphorus and fluorine atom. Now, in second case also, there will be also strong repulsive forces between the second fluorine acquiring the delta negative charge, and here also we will be having strong repulsive forces between the lone pair and the third fluorine atom acquiring the delta negative charge. Due to which, what's going to happen? Hopefully you are getting this diagram in 3 dimensions. In this case, what's going to happen? Due to these repulsive forces, the bond angle will be contracted, or we can say the bond angle will decrease, taking its value from standard value of 109 degrees and 28 minutes of tetrahedral geometry to the 96.3 degrees. So here bond angle has been reduced to the 96.3 degrees from the standard tetrahedral angle of 109 degrees and 28 minutes. Now, let's talk about the PCl3. Now I'm making the structure of PCl3. That's the phosphorus. Again, it's sp3 hybridized with a lone pair of electron. That's the first bond pair with first chlorine. That's the second bond pair with second chlorine, and that's the third bond pair with the third chlorine. Now here we all know that chlorine is more electronegative than phosphorus. So the chlorine will tend to attract the shared pair of electron towards itself, thereby acquiring the delta dash negative charge, and phosphorus will acquire a delta dash positive charge. And second chlorine also, the chlorine being more electronegative element will attract the shared pair of electron towards itself, thereby acquiring the delta dash negative charge, and phosphorus will acquire a delta dash positive charge. And same goes to the third fluorine. Third chlorine. The third chlorine will also attract the shared pair of electron towards itself, thereby acquiring the delta dash negative charge, and again phosphorus will acquire a delta dash positive charge. Now, what's gonna happen? One thing I'm mentioning over here, that the electronegativity, the electronegativity of chlorine is less than that of fluorine, due to which the magnitude of delta negative charge, the magnitude of delta dash, more accurately delta dash negative charge of chlorine will be less than delta negative charge of fluorine, due to which in case of PCl3 we are having the lone pair of electron. That's again a sort of negative charge. Now, the magnitude of delta dash negative is less than the magnitude of delta negative of fluorine. So there will be the repulsive forces, but these repulsive forces will be weaker comparatively PF3. So I am writing weaker repulsive forces comparatively PF3. Here also we are having the weaker repulsive forces between the lone pair of phosphorus and the chlorine having delta dash negative charge, and here also we are having one more repulsive force which is weaker between the lone pair of phosphorus and the chlorine acquiring delta dash negative charge. So due to these weaker repulsive forces, there will be the contraction of bond angle, but to a less extent. There will be the contraction of bond angle, but to the less extent. So I am mentioning contraction of bond angle will be less comparatively PF3. So thereby the bond angle in PCl3, I am writing thereby bond angle in PCl3 will be greater than the bond angle in PF3. So what's the value of bond angle in PCl3? It's 100 degrees. So you can easily see that in case of PF3 we are having the bond angle of 96.3 degrees due to the strong repulsive forces between the lone pair of phosphorus and a fluorine with a delta negative charge. But in case of PCl3, we are having weaker repulsive forces between the lone pair of phosphorus and the delta dash negative charge of the chlorine. Thereby, contraction of bond angle will be less in case of PCl3 comparatively PF3. So, the bond angle of PCl3 will be greater than the bond angle of PF3. So, in PCl3, we are having the bond angle of 100 degrees, and in case of PF3, we are having the bond angle of 96.3 degrees. All this happened because of the lesser electronegativity of chlorine comparatively fluorine. So the chlorine will acquire a delta dash negative charge whose magnitude will be less than the delta negative charge of the fluorine. So let me mark the bond angles for the PF3, PCl3, PBr3 and the PI3. In case of PF3, we got the bond angle 96.3 degrees. In case of PCl3, we got the bond angles to be 100 degrees. In case of PBr3, we will be having the bond angle to be 101 degrees, and in case of PI3 the bond angle will further increase to the 102 degrees. All this is happening because of decreasing electronegativity down the group. So that's all for today. I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please do like, subscribe and share this channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.